In this video, I will show you how to implement a lower triangular matrix using row major representation as well as column major representation. So I am using the same project for matrices. Already I have defined a structure for a matrix having array of fixed size and n for dimensions. This is structure we have already used in diagonal matrix, so I am using the same one. So you should get the idea how we can modify the existing program to make it as a new program. Instead of writing the whole program from the beginning, I will modify this one. Now this matrix is going to be a lower triangular matrix, so we don't know the size. We cannot take a fixed size, so I have to take a pointer and I will create an array dynamically for a required size. So the first thing, let us create an array. Inside the main function, I have created an object of matrix M. Then here, I will take the dimension of a matrix from keyboard. So let us give a message and ask what is the dimensions. Enter dimension. Then scanf %id, we will take dimension in m.n. See, m is a variable of type matrix and m is having variable n, that is data member n, that is for the dimension. Now once we know the dimension, we should create an array. So m.a is a pointer for an array. Here I should allocate the memory from heap. For that I will call malloc function. Now the question is, what is the size of an array that we need? We already know the number of non-zero elements present in lower triangular matrix. We have already seen the formula, that is n into n plus 1 by 2. These many number of non-zero elements, and this should be multiplied with size of integer. This will create an array of required size for storing non-zero elements that are n into n plus 1 by 2. Now the array is ready. Now we should have the functions for storing an element and retrieving an element. So we should have the function for set and get. So already I have the body of these functions. I will implement set function. So set function will take a matrix and it will take I and j as the indices and the element x to be inserted. So what is the element to be inserted and where it should be inserted? So lower triangular will have the elements only if I is greater than or equal to j. So if I is greater than or equal to j, then only the element is non-zero. So we will store the element in an array of at a location I into I minus 1 by 2 plus j minus 1. This is the formula we have seen. There we will store the element. See, it's so simple. We have already seen in a diagonal matrix it was I minus 1, but now instead of I minus 1, the formula has changed. Rest of the things are same. So that's all in set function. Now let us implement get function. So in get function, it is taking parameters matrix I and j are the indices. We want an element from an index I comma j. So here also the same condition, if I is greater than or equal to j, then only we have non-zero element. So we will return an element from location I into I minus 1 by 2 plus j minus 1, same location. Otherwise, we will return 0, means the element is 0. If I is greater than j, then it is non-zero element, otherwise it is a 0 element. Now this is the display function already we have used for diagonal matrix. So here that time I wrote for loops starting from 0 onwards. Now let us make them from 1 onwards so that we can properly use the formula without changing the formula. So I and j both are starting from 1 and ending at n. Now here non-zero element will be if I is greater than or equal to j, and the element is at a location I into I minus 1 by 2 plus j minus 1. So this is the place from where you can get the non-zero elements, otherwise the element is 0. So that's all. Now inside the main function, I will try to read all the elements of a matrix from the keyboard, then display them. So for reading all the elements of a matrix, I will say printf enter all elements. Then using for loop, I should read all the elements of a matrix. So for that, I require variables I and j for running two for loops. So matrix has to be accessed using two nested for loops. So for I assign 1, I is less than or equal to m dot n and I plus plus. Then for j assign 1, j is less than or equal to m dot n and j plus plus. These are the two for loops. Now inside for loop, I will read a value in a variable percentile d ampersand x. For reading a value also I need a variable, so I will declare the variable. Then I should set a value in a matrix at index I comma j, and the value to be inserted is x. So I should set the value at that particular location in the matrix using the set function. So here I will declare one more variable x. Then after reading all the values, I'll give a line gap. Then I will call display function by passing matrix M. Now let us run the program. Here is an error. Member reference type struct matrix is a pointer. Yeah, here we have taken a pointer, but I am using dot operator. I should use arrow operator. And remember one more thing, as we are using malloc function, stdlib should also be included. So I have changed it to arrow m dot m arrow a. Let us run it now. Yes, it's successful. Now here it's asking for dimensions. So the dimensions are 4 by 4. So I'll just give 4. Now enter all the elements. I will enter the elements 2, 0, 0, 0. This is the first row I am entering. See, I am giving zeros also. Then 1, 3, 0, 0. Then 1, 2, 3, and 0. And the last is 1, 2, 3, 4. So I am giving all the elements of a matrix. See, I got the same matrix. So how this is working is, when I have entered 2, 0, 0, 0, so this for loop has executed for the entire row, and it has called 4 times. First it will read 2, then it will set it, then 0, then it will set, and again for remaining 2 zeros it will set. So it will set all the values here. See, these all 4 values are set by this scanf and set function, and this loop will repeat it for 4 times. The next row, again this loop will repeat for 4 times. So if you check this set function will store the value only if it is non-zero. If I is greater than 0, then only it will store, otherwise it will not store. So that's all. This is the implementation of lower triangular matrix using row major representation. Now I will quickly modify this and make it as column major representation. See what are the changes I have to do. First of all, this is the matrix structure. Let it be same. Then this set and get and display function will come to them afterwards. Here the matrix is created. Then enter the dimension. And the malloc, what should be the size of a matrix? It should be same. Then here suppose I want to create a matrix and display it, it should be same only. And I will be calling set function. So everything remains same inside the main function. What all I want to do in the main function, same thing I'll be doing. Then going to the set function. Inside set function, this formula will change. If you remember the formula for column major representation, the formula was n into, so this is m arrow n into j minus 1, yes, then plus j minus 2 into j minus 1 by 2 plus I minus j. This was the formula. So already I have explained you this formula. The same formula I am using it here for setting the values. Then I will copy this formula, and for get also I should use the same formula. Then in display also I should follow the same formula. Yes. Now the elements will be stored column wise. Whatever the way they may be stored, this set will store the values and display will display the values. See, if you look from the main function side, main function doesn't bother how the elements are stored and retrieved. Main function is giving all the elements and it want all the elements, so display should display all the elements. So who is storing them? Set. Who will display them? Display. So whatever the elements we have given, we should get back the same elements. Let us run the program. Oh, there's an error. See, here it is call by value, m is call by value, so it is a dot. So it's not arrow, it is dot inside the display function. Then here in get function also, it's not an arrow, it is dot. Actually, I copied this one. See, this type of problem arises when you try to modify the existing program. Then you may do some mistakes and you may get those errors. And sometimes these mistakes and these errors are very much time consuming. It may take a lot of time for removing them. So it's better you retype the program from the beginning. But if you are able to convert it error free, then it will save a lot of time. Let us run the program once again. Yes, it's running. There were two errors, I have removed them. Now the dimensions, I want to give dimensions as 5. I'll give the same elements, 1, 4 zeros, then 1, 2, 3 zeros, then 1, 2, 3, 2 zeros, then 1, 2, 3, 4, then one more 0, then 1, 2, 3, 4, 5. Yes, I got all the elements. Yes, they are stored properly by using this column measure formula. So that's it for a lower triangular matrix. We have seen both the implementations. So row measure as well as column measure representations we saw.